We're live. Welcome back.
Awesome. Welcome to our May General Assembly, everybody, where we will cover what's going on in the baseline protocol and adjacent worlds with all of the great work that our community members do inside and outside of the baseline protocol. So as usual, we'll go through our agenda where we have all of our work groups give an update on what's going on. We'll leave some room for discussions in between. And then at the end, we'll have an open floor where anyone can feel free to share what they're up to or recent deep dives they've been going on or things like that. So with that, I'll start out with the outreach updates. So Mark Heddle, our outreach chair, is not on stream yet, but I will take it over. So our outreach team has mainly been focusing on the outreach roadmap items and writing the RFPs that go behind there. So the main work that needs to get done in the outreach world to support the technical work, making sure that it's understandable to technical and non-technical people, as well as just having nicely packaged content around the capabilities and demonstrations of a baseline protocol implementation. That will all be focused on by the outreach team this year. And we have an RFP that explains in detail what the objectives and requirements are for hosting and maintaining that work. And we also have the opportunity for any individual or groups of people to join the effort this year for some grant funds. So as I mentioned, we'll get into that a little further in the stream when we're talking about the roadmap and the RFPs themselves. But since our last call, the Consensus by CoinDesk event took place at the end of April. We had a few of our teammates there in person, as well as some who are not on stream, but Ananth, Mark, Keith, Yoav, myself, we were all there. I think that's it from who's on call right now, but any feedback on how Consensus by CoinDesk was? The talks, the side events, or anything like that?
That was my first kind of Ethereum or more broad crypto blockchain focused event that was kind of that style, where it was a lot of just booths. It was kind of a more traditional style event where there's a lot of booths with each sponsoring company giving kind of their pitch and their just information about what they're up to, as opposed to kind of the more Ethereum centered ones seem to be a lot more technical. A lot of, the center focus is the talks as opposed to, learning more about the different companies. But I kind of appreciated that because the ecosystem grows so fast and there's so many companies making so many like very useful tooling for developers in the ecosystem. And it can be kind of hard to scope out all of these different things just on your own, just like trying to find articles or Googling it, research all that. So to have like one place where you can just go booth to booth, person to person, and kind of see what they're up to and how it can, potentially help you in your own like work at home. It's kind of, it's different. It's not that one's better than the other, but it's kind of nice to be able to do that and see what everyone's up to.
Yeah. And I think after going to a few conferences with that style, Consensus itself was a little more organized and like quieter, where you could actually have the conversations with the people you're talking to. It was pretty DeFi heavy, I noticed. Lots of exchanges or counting and other types of projects going on, as well as like a really big enterprisey presence, which is, of course, one of our lanes for the baseline community. But like KPMG hosted a happy hour, which was one of their first big events at a Web3 conference. And it was kind of like, it was matching the tech scene and enterprise scene of Austin itself. So it was a cool conference. I think all of the talks are recorded and posted online. A lot of stuff about regulation, things like that. Of course, the baseline adjacent topics like ZK, enterprise use and stuff as well. So feel free to sift through those and let us know if you learn anything from those videos. But Awesome. So I don't know what the next large conference is that will have baseliners attending. Is anyone here going to a conference in the near future? Maybe not. Maybe it's just the busy summertime starting. But as always, our outreach team will be keeping up with our events tracker and targeting the places that baseline members should be having a presence at. All right. And with that, I will hand over to you, Mark Rimza, as one of the sub outreach topics of the research group, if you want to give us an update on what's going on there.
Sure. So one subtopic of the research work group is the fact that the Blip One and international supply chain efforts have sunsetted, or maybe a better word is paused for now. And recently I just submitted a PR to the baseline repository to add all the resources that have come out of this working group, so that it's easier to access for the broader baseline community, so that anybody who's accessing the repo, looking through the examples, can take a look at any of the resources that the group has produced here and maybe get a better understanding of the baseline protocol. So one of the things I can do right now is just walk through some of the resources just to remind everybody of what the work group has done, and then just to remind everybody, and if they want to check it out later, they can, if the PR gets through, or once we find the right place to put it out there for the community. Can everybody see this?
Yes, we
Yep.
can.
All right, so I'll just go through the resources in the order that I've sort of listed them in the PR in terms of the like the history of the working group. So the first thing to go through would be the supply chain choreography. So this right here, all the work done in this in these two working groups stems from the lens of an international supply chain, which is a multi-party workflow, multi-party use case. That's a good way to represent how the baseline protocol works, why it's effective, how it can bring benefits to businesses, any enterprise that wants to have a trustless flow of automation, business processes. This supply chain choreography gives a good overview of how different documents are proposed and agreed upon by multiple parties throughout an entire workflow. So, you start with an MSA, it's proposed by the supplier, it's agreed to by the buyer. It's like a state proposal and then acceptance. And then from there, that would be signaled to all these parties where you could move on. And then the buyer could create an order, for instance. So very simple explanation of this here, but this is just a good bird's eye view of what a multi-party workflow looks like, and a good way to think about how you could break down baseline workflows if you or a different company are thinking about baselining your own process. Next up here would be the sequence diagram, which Maron in the work group created. This gives an idea of all the different parties that are involved in this international supply chain, who's creating these documents, who's signing these documents, and then if they need to be anchored to a CCSM. So some of the materials in this work group reference decisions on when to use a CCSM or not, and then later as we get through some of the materials, everything's using a CCSM as a verifiable timestamp for anytime a state change is made. But the decisions between when to use a CCSM or not, or when to use a zero knowledge proof, they're all included in a lot of the materials that are produced here. And then next up would be the story journey, where we have a general user story for the entire flow of an international supply chain. We have the personas listed here, and then we have all of the documents that are included in this international supply chain, and comments and considerations about the about each document, about who it's initiated by, who the approvals are made by, what some of the properties of these documents are, whether it needs ZKP validation, whether it needs anchoring, and also listed here that's important to note is references to other documents using nested verifiable credentials as proof of previous acceptances or like approved state changes from other documents that feed into new documents that are created. This is included here as well. And this provides a good basis for how business and technical requirements can be created for a supply chain demo that would be baseline standard compliant here. So building on this story journey that was created are these story journey advancement predicates, which I think give a decent idea of how people can conceptualize the flow of a baseline process where you have a bunch of parties that come together. You start with an initial state, and then you propose a state, and then you accept that state change. So all of these give more granular steps for how you could create a purchase order, what goes into that decision, and how it moves with more technical details. And from there, we created supply chain demo user stories that take all of the rules for advancement of each step of that supply chain process and break it out into epics and user stories and even example verifiable credentials that contain all of the properties from the story journey, sections for proofs, sections for signatures, rules about why you would need a signature, why you would need to verify a zero knowledge proof, user story descriptions of, as a buyer, I need to verify the signature so that I know the catalog has been approved so I can create a purchase order. And what it does is it takes a lot of the technical discussions that happened and a lot of the discussions about the business requirements, and it merges them together into these user stories that developers, if they were to come across these, could pick it up, and maybe they're not fully complete, but it gives a much better idea of how you could create a trustless supply chain or some sort of trustless application that takes these documents or state objects and synchronizes them and verifies them with zero knowledge proofs, anchors them to CCSM, and globally signals these state changes for everybody as it's like a common bulletin board, I guess you could say. So that's a full overview, high level overview of the work group. I just submitted a PR to the baseline repo, so stay tuned for that. If you're a core dev, please review it and let me know if that's the best place to put it or not. Are there any questions on this work here from anyone? Sounds like no.
No, I think it looks good, and I'm glad to hear that it's going to be accessible within the repo, since that's the place that anyone can access who's just finding the project, and then they can have the pointers to where the docs actually live. So thanks for doing that. And then also it seems that you have some recent blogs that you've done on the Mesh blog page related to baselining. If you want to give us some info on those and maybe share your screen and walk us through, and I can send them on the YouTube chat at the same time.
Yeah, sure. Our team, the Mesh team, has released some blogs, and I can't take all the credit. These are largely from the mind of Andreas Freund. So these three blogs right here, if you can see my mouse, are the most recent blogs that our team has released. The first one is about zero knowledge IoT, how the baseline protocol can secure the edge of networks. This is a great blog that talks about IoT devices and how they have specific limitations, how they lack a trusted verifiable identity, how they can't verifiably prove the source of their produced data, and that they can't prove any transformations of their data are done provably correctly. And all these properties make IoT devices a prime candidate for verifiable attestations in the form of zero knowledge proofs. When you take these verifiable attestations of identity, location, membership, all things that our team has worked on, Keith and Yoav created a trusted location service that we did with a mobility consortium. When you take these things, it gives, it allows IoT devices to be equal agents as humans in specific processes. And you can create baseline processes. You can secure the edge of networks because everything is done in zero trust, under zero knowledge. And overall, this is a really, really great report that provides a lot of insight into the reasoning and logic behind the baseline protocol, how it can secure your system, and how you can collaborate with others trustlessly by not trusting, but verifying always, and working through that way. So this is a great blog. Definitely read this. Another one that we released is the baseline protocol across industries, specifically the industry of telecommunications. And in this article, we talk about just some of the general things that we usually touch on in each blog about why multi-party zero trust under zero knowledge is needed because of regulatory and cybersecurity pressure right now. And then later in the article, we talk about why telecommunications in particular is an industry that needs multi-party zero trust under zero knowledge. It's because they have so many parties that they coordinate with to deliver end-to-end services. And we provide a simple example here of providing end-to-end connectivity through telecom. If you want to connect a Singapore office to a New York office, you need to go through 4 different companies to provide that connectivity service between the 2 offices, which means there's a lot of trust assumptions involved there. There's cybersecurity vulnerabilities, and the best way to shore up all of these things, ensure that you're regulatory compliant and that you're not opening yourself up to undue cybersecurity risk, is to use the baseline protocol and secure everything in that way. So another thing that's cool about this article is it talks about how telecom is thinking about zero trust and zero knowledge. They've created some of their own standards. And another thing highlighted here too is the MEF Showcase, which is a quarterly membership meeting which focuses on these multi-party zero trust under zero knowledge use cases, and is something that our consensus mesh team is working on. We're working on using the ZK EVM as the private verifiably correct execution framework for trusted business automation between multiple parties, and then using DAOs as the governance and business automation framework that these processes can be run in. So definitely check this article out to get an idea of what telecom is doing in the realm of zero trust and zero knowledge, and more insight into what our team is doing to further advance the baseline protocol here in this way. I think it again is worth noting that a lot of these pilots mentioned here in the article, they're all within the family of baseline, using the baseline pattern to achieve this trust and synchronicity between multiple parties and heightened security. And then finally, back to the topic of consensus, I gave a talk at the Hyperledger booth about decentralized business automation as a service. So this sort of goes hand in hand with that telecommunications article, because we're working on building decentralized business automation. And we're starting with telecom first. And this article gives just a little summary of the presentation that I gave. And I could blow up this little diagram here if it works. I guess it isn't really working, but we're working on using ZK EVMs and bridges and Web 2 systems to connect all these Web 2 systems and do trusted, decentralized business automation here. So take a look at this article, or just watch my presentation. We have a link here if you want to see what we talked about and get a little preview of some of the work that our team is doing. I talked about it a little bit already, but we're using ZK EVM and DAOs and packaging it all together as hosted services for companies to make it easier to set up baseline pattern multi-party zero trust under zero knowledge solutions that they're looking for. And we have interest right now in telecom, and there are some other industries like mobility or insurance that are also interested in waiting for these solutions as well. So that's all I have to say on these articles, but Andreas, you contributed too. If there's anything else you want to share about them, please do.
Awesome. Thanks for talking about baseline and these reports that you're generating and giving us content to share through the baseline community as well. Alrighty, so Yoav, I'll hand over to you to tell us what's going on in the core developer world.
Can do. Thank you, Mark. Thank you so much. So core dev, starting with BRI 3, the SRI simple reference implementation. It is currently on milestone 4 of its grant request, and is making pretty good progress on that milestone. The team is currently kind of wrapping up on the use case doc that we've been working on. And this doc, I think we spoke about it as well on the last GA, but this doc kind of outlines the architecture that would be required to implement kind of a basic use case. This doc kind of is to get everybody on the same page, kind of architecturally speaking, of what developing that would entail, so that we can then come to a consensus on what the like final use case would be, and then go about implementing it. So yeah, that's kind of where the use case doc is. Milestone 4 itself kind of requires, part of its completion is to have a complete use case. So that doc is kind of a really big first step in getting there. Once that doc's in place, it would be much smoother. It'll be a pretty quick ride to having that use case put together. Milestone 4 also outlines ZKP components, requiring that all proofs are generated and stored accordingly and can be verified by participants, as well as a fully functioning happy path test case, which would include those ZKP components having everything stored correctly and be generated in zero knowledge. Current state of those things, there is a happy path end-to-end test case that creates 2 BPI subjects and a work group, and adds the created BPI subjects to that work group. And I can kind of show that PR real quick, just to give an idea of what that would look like. So kind of disclaimer with what I just said, this test case is kind of the beginnings of that, the beginnings of satisfying that milestone 4 requirement. It does not include all of the ZKP components necessary to satisfy milestone 4, but it does, like I said, create those work groups, work steps, and add them to the work group. So it is kind of the beginnings of finishing that requirement to satisfy the rest of this milestone. But the spec and all of the architecture kind of surrounding making this work is all very in line with the architecture of BRI 3, in that it's all meant to be kind of our main, the main focal point of how everything is being designed is to be as simple as possible, to be kind of a true MVP, in the sense that it can be sort of the here's a fun play on words, the baseline of an implementation that anybody can pick up and sort of kind of quickly understand how it's been put together and build on top of it without there being a lot of extra or unnecessary kind of fluff built into it. So, you know, not to go line by line in code, but this is kind of that test case, which, you know, does what you would expect. It creates all the different participants. It utilizes the Prisma to seed some keys, and then it uses those keys to spin up all of the necessary components, storing everything that it needs to, creates the work group, it checks that the proper response gets returned from the server, and yeah, and then verifies that everything is kind of as expected. So from that sense, that's kind of where milestone 4 is at the moment. It's coming along. Everything that it requires, being that end-to-end case that has the ZKP components, is all kind of very close to a stage where the true necessary implementation can be worked on. And in that sense would be wrapping up milestone 4 once those things are fully complete. So that's BRI 3's current status. The core dev group is also working on interoperability for the Interop Fest that we are planning. So there is a sort of separate interoperability work group, which many of the members kind of overlap with the BRI 3 work group. But this work group is going through all of the interop related specs in the standard and kind of deciding exactly how those specs would have to be implemented within the 2 BRIs involved, which is BRI 1 and BRI 3, in order to kind of achieve that interoperability for the purposes of the demo for the Interop Fest. So we're going through kind of every single requirement. We're seeing what it would take to implement, or if not, what is already implemented, and what is already interoperable between the two, if there isn't, if that component is already satisfied with the current state of the both of them. The team's also kind of outlining an API spec for interoperability. And the last time we met, we posed a couple questions for the group, some kind of to-do items to decide on, and just to kind of give an idea of what we're thinking about. These are things like deciding if a specific did method needs to be predetermined for the two, for interoperability in general, or the 2 BRIs specifically, or if it would be satisfactory to allow them to kind of choose a did method freely, as well as if there's a need to support each other's login methods, and if there is, if the use of a universal resolver is necessary. So these are kind of things that we are posing to the group, things that are kind of just being thought about alongside all of these specifications. There's also a suggested use case being worked out. The interoperability kind of requires that the 2 implementations are aligned on their use case, right, as they will be kind of working together. So this proposed use case thus far that we've been thinking about, it involves synchronizing banking data. It's not yet kind of the final use case. We're still discussing maybe tweaking that one or suggesting new ones, but that's kind of where we're at. I can show a little bit of kind of the notes to just show what all of that looks like in practice. So from the interop work group notes document, and all of this is kind of in the baseline open source public domain in Google Drive. Here's the suggested use case I just mentioned. So the master data syncing of banking data, and it goes through kind of what the 2 BPIs would look like in a work group and the workflow between them. And then this is the work for all of the interop requirements. So as you can see, like a requirement here involving interoperability is pasted, and then discussed below what it would, what we would need or what we have to satisfy that requirement. And for anyone who's looked at the spec, it's long. and there's a lot of interop. So this is kind of a long effort. It's gonna take some time, but is pretty necessary in order to demonstrate the true power of baseline, because really, you know, it comes out of its shell with interoperability, with utilizing more than one party, you know, multi-party, of course. So this is kind of a necessary evil to go through and make sure that we can take care of this. And here we have the API spec that we worked on in the last few work group sessions, along with those kind of to-do questions that I mentioned earlier. Yeah, so that's kind of the state of those two work groups. Andreas, if you have anything to add for interop, or Keith, if you have anything to add for BRI, feel free, but that's my update.
All good. Excellent job.
Yeah, very well done.
Thank you.
Awesome. Yeah, thanks for walking us through that in a concise manner. A lot of work going on, and it's all connected as we see. So thanks for that. All right. So next update, Andreas, if you can give us an update on the standard itself.
Or I'll apologies for not turning my camera on. I have hardware issues I've been having for weeks. I can't figure it out. Anyway, so hence no smiley face from me except my picture. The so where we're at. So we finally came to an agreement with the in the PGB, well, between Charles, Dan, and I, effectively, on what testability actually means with regard to requirement, which ends up being a logical test of the requirement. So you have to write a logical test for the requirement, which with preconditioned test steps and done criteria, right? Success criteria for that test, such that implementers can basically follow along and relatively easily write a test. Well, I don't know about easily, but can write a test and don't have to you know, think too deeply about how to think about that requirement. That's the good news. The bad news is that writing such testability statements is a tad time consuming. Well, thanks to ChatGPT, this is less time consuming than otherwise. You can write nice prompts and insert the requirement and give any definitions that have been written around that requirement, and then it actually gives you a good place to start. So currently section 7 has been used as the the spec has been used as which is around storage, has been used as the guinea pig for that. Has been updated and merged. Section 8 PR is out. I'm currently working on section 6. We can probably get away with some very minor tweaks to section 2, which we already have testability statements for. And then that leaves us with sections 3, 4, and 5. So I hope section 6 is slightly expansive, as well as 5. So I hope to have 6 done in the next couple of weeks to create a PR. I think there are something on the order of 80 to 100 requirements in that section 6. So I think I have to get to I think I'm at 248 or something like that, 50, and I'm still need to get up to like 279. Plus there are some optional and should requirements in there too. So getting getting there slowly, but surely. Yeah, so that's the journey of the spec. Once we have all the testability statements added, we can move it to a full draft status, hopefully during the summer sometime. And then we just have to wait for the interop demo to be completed, and the documentation of that demo and BRI 1 and BRI 3 to be added to to the PR, such that we can move the standard to a final specification status, hopefully sometime early next year. And then we can say that is done. So the key, I think, is that what we need to do is to drive more outreach, get people involved, because a standard is only as good as as the people who are actually use it and implementing it and have it companies and enterprises use it. So that's an important piece. So yeah, that's the update from the standards working group and the editors.
Awesome. Can we segue into the TSC update next, Andreas?
TSC update, yes. So we already had the interop RFP out and published, waiting for participants to submit. We have a little over a month left, I think. 6:30 or something like that. We might have to extend that deadline. And we also, the TSC, agreed on the wording of the outreach / roadshow RFP that has been published. We apparently already have someone who is interested in submitting a proposal. So that brings us to funding. Funding is really crucial. We need to do, and it's the TSC job to now do a concerted effort before the summer months kick in, where there's basically nothing going to happen, in order to start generating some donations. We have commitments for matching, but so we need so for the interop RFP, we have a commitment as a matching fund. So we need at least 2 participants, 25 that would receive 25K each. So we need to raise like 25K to get a 25K match. And again, for the roadmap, the outreach RFP, I think we have it at 25 or 30. I forgot exactly what it is. So we de facto need to net raise around 50K for those 2 RFPs to get going. We are we had it's like Mark already talked about the blogs that TSC has published, and we will have another blog coming out next week. It's going to be sort of like a surprise. It's like a box of chocolate. You never know what you're going to get until it's out. So suspension a little bit, and then we have already the another one for June on the docket. Otherwise, we have the TSC has made a proposal to the PGB to for this year, 2023 RFPs, suspend the 25% grant fee that is split between the EA and Oasis, because potential grantees have voiced significant concern about that 25%, which would be on top of the 8% that the open collective platform collects from a donation. So we'll see how that goes. Hopeful that we can get this waived at least for this year, such that we can get in more sponsors, new sponsors, and get in grantees that we can convert to sponsors in 2024. So that's the goal, and that's the mission, and that's the what the TSC is accountable for. Yeah, that's it as far as the TSC is concerned.
Awesome, thanks. Any questions from the group here about any of the work going on in the baseline community? All right, I'll take that as a sign that we explained things well. And now time for our open floor. So anybody on call want to tell us what's going on in their worlds, in their project work, any deep dives they've gone on, any new learnings, questions they're pondering, or anything like that?
Hi, Sonal. I just wanted to, tell the guys that, I really appreciate the effort they're taking to catalog their work and the systematic way they're building their user stories. I think that really kind of differentiates Baseline from most of the other projects that we see coming out of, the Web3 space, right? So say like a great job, really appreciate it.
Awesome. Yeah, thanks for sharing that feedback. Jack, Chung, others, what is going on your projects at this time?
Hi. Yeah. So we right now are kind of tumbling down the rabbit hole of building a backend for Noir using Halo 2. I think something kind of contextual to Baseline would be, it seems like the kind of the lingua franca of Baseline right now is CIRCOM, right? So yeah, I'm kind of wondering, I guess, if there's been any kind of exploration around some of the other proving systems. I know Andres has talked a lot about Plunky 2 before. Is that something that, and including kind of interoperability as well, is there kind of interest in looking at the different advancements that have come out even in like the past year or so, and seeing what kind of proving enhancements there could be?
I think I could jump in here. So I work for RISC-0. We have our own ZK VM, primarily programmed today in Rust, and we are looking at ways we can support Baseline, particularly even being able to run business logic and things written in languages like Rust. So we're trying to figure out what the integration story looks like and how we can support as we go to implementations, for sure.
And that's a super compelling one because RISC-0, RISC-V, the kind of, is that actually how that works? Are you able to essentially take like the RISC-V instruction set? Let's say you've got something running that. Can you essentially verify those sorts of machines in RISC-0, or is it really kind of a standalone thing?
I don't want to turn this into a RISC-0 ZKVM call, but yeah, that's the technical approach. Is we from inside the proof code, it just looks like a RISC-V small computer, a 32-bit, a couple hundred megs of RAM machine, and you can do whatever work you need to do. And I think the places where that might work well with Baseline are places where you want to plumb things like existing message formats, serialization formats, all the way through into the proof code. where, maybe you might be more familiar with Solidity, so it's easier to write the business logic there. But because you have this extra baggage of like wanting to unpack a whole JWT or something like that, rather than rebuild all of that from scratch, you could lean on existing library code and do it through ZKVM or through Bonsai.
Yeah, it certainly seems like a compelling application, especially like looking at the microcontrollers, IoT, just having that entire stack fully verified, essentially, or at least the controller itself be entirely running verified code. Seems very interesting.
I mean, generally speaking, especially for interop, you just need to agree on the prover system, right? And then depending on the prover system, you need to then decide which trusted setup to use or not, and therefore also to trust. So we're probably going to go for the interop demo with something that's simple. But I think and I think it's really doesn't really matter whether you're using Noir or some other DSL, Circom or NARC for your circuits. In the end, it's important what comes out at the end, and that that how to what's the proving system, what are the verification keys, I mean, what's the witness and so forth, so that you can verify the proofs. And it's important to understand what those proofs mean. Therefore, the predicate that is that the proofs express, right, is important to understand, because otherwise the proofs themselves are meaningless, right? Unless I know what I'm proving. It's like I'm having a hell of a fun time, going through the prover systems of the or ZK EVM, where you're using Starks and then going into and then generating the snark, and there are so many subtleties and nuances and optimizations that can still be done. It's at this point in time, it's still very complex, and it has to be, because you're simulating a CPU, right? In anything that is ZK, whether there's an E in front of the VM or not, whether it's a ZK JVM or whatever, you're simulating a CPU, so that is by design very, very complex. Now, the question for baseline is, how do you plug that? And that's where it's like where zero comes in. Where and how do you plug these execution frameworks in most efficiently and effectively, right? It's and how much effort do you want to expand on that, especially around with regard to compute, because these provers aren't cheap, typically, right? Unless you have you use proper optimizations. But if you're running things that are over 64-bit on a 64-bit machine, you are running into trouble, right? So you're incurring significant overhead. Hence, it's really important that we're looking at sort of like CPU optimized prover systems that are attuned to current CPU architectures. GPU architectures. Hence, the work that RISC-0 and others are doing is really important. I think we're at a point where we kind of see where it's going, but you know, it's like where I'm still getting tripped up is you know, I need to run like a 96 core, 128 core machine with like 512 gigs of RAM, right? In order to get somewhat of an appreciable performance. That is not really a long-term sustainable model, except for very, very, very high value use cases. It's just simply not. I don't believe, right? I mean, the only reason why FPGA boards are so popular is because they're used in high frequency trading, and they generate hundreds of millions of dollars every day, right? That's why it's okay to invest, you know, like $500,000 to $1 million a board, and then the appropriate operating cost, and you know, buying a few hundred of those at a time, right? But only for that one use case, basically. Everything else is like, eh. So it becomes really important that we think about on the advancements of how to you know, move the systems along to make them much more compute friendly. I think that's the next, that's a big challenge coming up. I don't know, Sean, what's your take there?
Yeah, I mean, I think everybody working on proving systems is real aware and concerned about performance. I think for sort of business logic, I would say, speaking for our ZKVM that I know the best, for kind of typical business logic scale things, you don't need that big of a machine. And we're working on getting stuff to typically fit within a couple gigs of RAM, and you know, hopefully a few seconds or tens of seconds on a normal CPU, and then of course much faster on a GPU. So the situation is getting better pretty rapidly across the board, including the stuff that we're working on. So we think we will converge on completely practical in a time frame that fits with what Baseline's doing. It's kind of one of our focuses.
That's all. I mean, that's awesome, and that's really really important, because you'll end up having to run this on you know, retail hardware.
Yeah, well, and there are actually two areas where people are really pushing on performance and memory footprint. One is there's a set of people who want to be able to generate proofs in browser, in WASM, and 32-bit WASM has some pretty severe limitations on how much memory you can use. So that's a big one. And then the other is on mobile, where it's not so much memory, because modern phones let you use a lot of RAM, but energy consumption is a big deal and thermals are a big deal. So we've got pressure to go much smaller than I think even a server application would need. And you know,
yes, I but until you have the server side figured out, it's really hard to go beyond that, because you don't, you know, you're yeah, I mean, doing stuff in WASM in browser is extremely painful, and then the trade-offs become severe with regard to also security. I think there is a path where you will have these type of prover systems run in their dedicated VMs on OS. Like, you know, you can run, like, you know, with hypervisor. There are ways how to do that, so you can access actually the CPUs directly, and I'm pretty sure this will come fairly quickly, where you'll be able to access these type of type of external resources from the browser, right? Because there's no way, the browser was never designed to be a high performance compute environment. And I think right now it's being incredibly overloaded because there are no real support, because the supporting infrastructure around the browser on the OS side is not there. And similarly, it's also on the mobile side. So I really see the big advancements coming on the operating system and chip maker side.
Yeah, chip makers are slow. Know a little bit about that. But yeah, no, I mean, it's going to be interesting to see how this all unfolds. I mean, we do have proof generation in browser working today. And I think there are a few groups that have built and run that way.
Right, but they're typically simple things like join split circuits.
Let me get back to, I'll look at exactly what it was that our team did. But I think in general, even though ZK is kind of a new area and Web3 as a slice of overall software is sort of a new and relatively small area, gaming is massive. And one of the things that we all benefit from is that the gaming people are putting a huge amount of pressure on every platform to get more and more and more performance.
Right. That's for sure.
So I mean, things like Web GPU and 64-bit WASM support and SIMD and WASM, those are all things that probably, a few of us by ourselves couldn't motivate, say, Google or Apple to put into their browsers, but we benefit from gaming and creative apps as well, all kind of wanting the same stuff. So,
and I think with generative AI,
the new hot hype area, but yeah, definitely.
Well, I mean, if you want to have personalized assistance, right, and not spill the individualized models across everything, which you don't want, you have to run the stuff in browser, unless you want to run it in a fat client.
Yeah, and the deployment story for like Chrome extensions, once you want to go outside of something WASM embeddable. Anyway, there's a whole like technical rabbit hole about why we're trying to kludge it together with exactly the technology that's shipping in browsers today, even though we know that it will eventually get better. But yeah, it's all stuff that we pay super close attention to.
Yeah. So, but I think that driver, like gaming, generative AI, we will be able to piggyback on that, on the improvements that are coming down that highway.
Yeah, and that some of that stuff manifests on the server side as well. I mean, I've been around long enough. I remember the original, SIMD and commodity x86 chips was really driven by gaming. It was, people want a Quake to run fast, and here we are. We have AVX 512 in our data center.
Yeah. I mean, I remember when the whole thing about it's like video cards, right? Video cards with their own CPUs, and then they were dedicated and GPUs, and how that came about in the 90s, and it was all driven by gaming.
Yeah, so I think that stuff is all good for us, and I mean, I keep pretty close track of developments in the CPU world, in semiconductor, but it'll benefit, I mean, even in business applications, because like things like ZKVM or some of the crypto acceleration you need for other blockchain infrastructure, all of that stuff is getting accelerated, even in server CPUs. But
yeah, I think that the on the mobile side, the next generation Snapdragon will have a lot of the features that we'll need.
Awesome. Thanks for engaging in the discussion. We always are able to fill up the entire open floor because there's so much to talk about. All right, so that will conclude our May General Assembly for the baseline protocol. We will have our next one in June. But next week we will be hosting Polygon ID on the baseline show. So please join the live studio again, or tune in live, or let us know if you need links to either. But again, thank you all, and we will see you next week.
Thank you, everyone.
Bye.